Hello everyone, thanks for coming. And for today I'm going to talk about Leafmap. And you can scan the QR code to get access to the slides. And I also send the link in the conference app in the chat so you can access that. And just curious, how many of you use Python? Okay, so roughly 80–90%. How many of you have used Leafmap before? Oh, cool. Okay, so maybe around 20, half a quarter people. And so hopefully after today, if you have never used it, you can try it out just using a browser. If you have already used it, it might introduce some of the new features that you're not aware of. And so my goal is actually to make things easier. So for you to access those open access data, and it makes it really easy for you to do the mapping and analysis using Jupyter and Python. So some of the things I'm going to introduce here, you can do that in desktop.js, but the point is that it will be browser-based, and you don't need to install any desktop software on your computer. You can just open any web browser, go to any cloud computing platform, and then you'll be able to do the visualization. So the package is called Leafmap, and you can go to the website, leafmap.org. And so I'm going to give a brief introduction, then I will show you some of the key features, basically give you the demos, and lastly we'll show you some ways you can deploy this on the web easily with couple lines of code, and then lastly we'll show you some additional resources if you want to learn more about Leafmap. So Leafmap is open source package they built on top of some open source mapping libraries. It's pretty new, only roughly I think I created in 2021, so it's only 3 years old. But a lot of people use that for their projects because it's really easy to use. Especially you're new to programming, you don't want to learn so many packages, and Leafmap might be reduce you the time that you need to learn packages. And again, it's open source. We welcome your contribution if you can. And also there's a website, leafmap.org, has a lot of tutorials, notebook examples. I think right now we have 95 notebook examples. So each notebook introduces some of the key features of the package. So you're welcome to check out the website, a lot of resources. And Leafmap support many mapping libraries. So these are all the Python-based mapping libraries. And you can see you might have used some of Folium or IPyLeaflet. And so also we can use some 3D functionality, for example, from MapLibre, also PyTech, something like that. And it's really easy to use, so you don't need to learn all those packages. All you need is just Leafmap, and then just import Leafmap. Then the default mapping backend is IPyLeaflet. It has the richest functionality. But if you want to switch to other mapping libraries, just import that as Leafmap, and everything else remains the same. So basically, it provides a unified API so that you don't need to learn all other packages. And all the source code are very much similar, XVector, XRaster, XCORD, XStack. So it can handle pretty much all the popular geospatial data format, either it's vector data, raster data. And so next I'm just go through a bunch of features. There's a lot of demo, and if the internet doesn't work, then you can watch it on your using your phone. And so let me see here. Oh, okay, it works. So the first one is that you can change base map. So this is similar, for example, to desktop QGIS, you can switch the base map. So again, this is just in Jupyter Notebook. So once you create a map, you can have those widgets to just switch the base map to whatever base map you like. So it utilize the XYZ services package that has hundreds of base map available. Just one click, you can switch. You can also search base map. So if those base map are not included in the XYZ services, but there's a quick map services. Those users of QGIS might have used that. So you can do the same thing. You can search a keyword, and then you can just load the base map pretty easily. So this one, you can also open any vector data locally. So either it's point, line, or polygon, it doesn't matter. If you want to do coding, you can do coding, but everything under the hood is executing some code. So this is all based on IPyLeaflet, and you can open points, lines, and polygon. You can customize the visualization, the symbology if you want to. And you can download OpenStreetMap, one line of code. So if you sometimes just need some data, okay, you want to play with the program, it's just one line of code, add OSM data from geocode or from address. Then we pull the data directly from OpenStreetMap, one line of code. So, so this, you can also add the vector data. So this one actually I just implemented yesterday when I started during the conference here. And you see the screenshot is not very good because my laptop is not as good as my desktop. But the idea is that sometimes if you have some vector data, you want to edit the attribute. For example, you might need to do some labeling for your machine learning algorithm. You have some point data, line data, it doesn't matter. You can load the data using whatever vector data format, anything that GeoPanda supports. And then you can just load it, and then you can click multiple. You can change it all at once. So you can change basically do the batch processing, change the labeling for your data. Either it's point, line, polygon, you can do the same thing. So it's very easy to use, very interactive. So this is changing the attribute, but you can also change the geometry. So if you have some vector data, you need to do some simple editing, you can open the data, and then you can just change it. You can also change the attribute if you want to, but this is only one by one individually. So if you need to change the geometry and also the attribute individually, you can use this one. And you can also read data from PostGIS database. So if you use database a lot, sometimes you need to do the query and then export the data so they can visualize on desktop.js. But using Leafmap, you can just do the same query and you directly pull the data, and then you can visualize it on the map directly without having to convert the data format. You can visualize raster data. So pretty much any raster data supported by raster.io or GDAL, you will be able to open that. And the data can be from local computer, or it can be from cloud, S3 or Google Cloud Storage, wherever you have HTTP access. If it's publicly accessible, or if you have the credentials set up correctly, you can load the data. So again, you can do it no coding, or you can just one line of code. Add the layer from anywhere, and you can change the color map, you can change the symbology, so it's really, really easy to use. If you ever need to visualize raster data using Jupyter, you probably need to set up the server, or you need to use other packages. It takes many lines of code to do that, but in Leafmap, it's one line or no coding. You can try it out. And also PM tiles. So PM tiles is very popular data format nowadays for visualizing data at scale. And especially all the new data, for example, overture data is provided in PM tiles format. So basically, you can stream the data on the fly. It's only getting the data based on your zoom level, based on your map view area. And this can help you visualize hundreds of gigabyte data without any problem. So this is for PM tiles. And lastly, I'm going to introduce a couple tools that you can create some map. For example, if you need to compare data side by side, you can also do this pretty easily. This one actually is deployed as a web app on Hugging Face. So if you are interested, I will show you more examples later. So you can compare images. For example, this image is from MaxR hosted on AWS. So you can put the data. This is for disaster management, so you can quickly visualize data side by side. And as you can see here, there's no coding, so you can deploy the app, and then anyone can go to your web app and then visualize that. Besides the split map, you can also do the link maps. So link maps basically means you can have multiple map views, and then it's all linked together side by side, and you can 2 by 2, 4 by 4, whatever way you want. So this is good for, especially for remote sensing data visualization. You have different spectral band combinations. Sometimes you just need to look at all of them so that you can see which feature may be highlighted. This can be useful. And also, there's a time slider. So if you have time series images, for example, in this case, is the planning imagery, global mosaic, right? So if you have a lot of images, you want to see that quickly, there's a time slider that you can slide through to see all the images, rather than adding tens of layers onto the map, all at once. So this, you can basically select the data layer you want, do the visualization. And you can also search and visualize data interactively. There are tons of data on the internet, so we have a lot of open access geospatial data on AWS, on Google, on a lot of other places. So using Leafmap, you can just provide a custom endpoint, or you can point to those direct AWS and Microsoft, and then you can search the data. You see here, there's no coding, and you can search the data, you can visualize it directly. So the point is that you can certainly, some of the data provider, they provide some of these for you to search, but you cannot directly integrate this one into your Python workflow. In Leafmap here, everything is in Python in Jupyter Notebook. So whatever data you search, there's a pointer to point to the data, then you can use for analysis directly. And so previous one showed you, for example, the Microsoft data, but you can, for example, also data from AWS. They hosted, for example, the Sentinel-2 image catalog. And if you just need to pull some data easy, to do some exploration, then just use the interface, one click, and then you can just search, and then you can visualize, change the bank combination. You can also do some simple calculation, for example, NDVI, whatever, so yeah, it's all supported, and then you can just visualize, you can compare, and all the data is like the entire, you have access to the entire data catalog. You can do whatever you want. So the point is that it's so much easier, so you don't need to worry about understanding how the stack catalog works, how to search and pass the query. Everything can be done using just one click or button, and then you can point to the data, then you can use the data for analysis. You can also source NASA data. So NASA has over a couple hundred petabytes of data. So if you need to have access to NASA data, you can also use this one to source. Just show a rectangle, you will get all the footprints. So these are all the JEDI, the LiDAR, space LiDAR data, so you can see what the cover is. And then if you want, then you can download the data with a couple lines of code. So this one built on top of the Earth Access package, so makes it easy to search and visualize NASA data. So it covers a variety of data sources from NASA, from Microsoft, Google, Amazon, so tons of data. You can also search your own, if you have your own custom endpoint, you can also provide the endpoint and then use the interface to search data, and it's really easy to use. Also Maxstar open data, so Maxstar released a lot of data for those natural disasters, high resolution. So, but it's hosted on AWS, but it's not so easy to use. So you need to download the data, and Leafmap basically you can directly access data and then creating the virtual mosaic, so they can easily compare the data side by side for different events. And also cloud optimized GeoTIFF. So this is pretty much nowadays the standards for visualize the hosting the data in the cloud for raster data. So you can open data directly from a local computer, or you can just point into the URL, and then you'll be able to stream the data on demand. Then you can just change the bank combination to whatever you want. It can be one single bank, it can be multi-spectral bank, so it's really easy to use. For example, you can also do this provide equation. You can quickly calculate, for example, the NDVI, and then you will render the data directly. So you don't have to download the data, you don't need to actually process the data on your local computer. Everything happens in the cloud. You can also query pixel values. So this is very common for desktop GIS, right? You load the raster, you want to check the pixel values. Leafmap can do that easily, just a simple button, then you can get the pixel values. This can be useful if you need to collect training samples for your machine learning algorithm. You can also export the points to a CSV or geodata frame. And besides visualization, so Leafmap has the white box tools built in, so it has over 500 tools available, so you can use it to do all kind of geospatial analysis, LiDAR analysis, hydrological analysis. It's free and open source. So for example, I can get a DEM, I can view the depressions, I can delete the stream flow, watershed, all kind of stuff. So you see the tools in here. So this is similar to QGIS the toolbox or ArcGIS toolbox, but it's open source and it's super fast because it's based on developed using the Rust language, and you can check out white box tools, so you can use it to do all kind of geospatial analysis. You can also visualize LiDAR data, so if you work with LiDAR data a lot, Leafmap, just one call and visualize data using different backends. Besides that, you can also visualize the regular raster data in 3D if there's something you want. So lastly, this is like if you need to create some cool animation, so you have some vector data. For example, this one shows you the evolution of the buildings based on the build year, so you can see the changes. And these are some of the nice tools that it might take you a lot of lines code to generate something like this. In Gmap, it's like one line of code. Just give me the data, provide the column you want, and then you will generate this one for you. So these are some of the key features I want to show you, and so it's based on IPyLeaf that. Another one I want to cover is the MapLibre. So this is another Python package they built on top of the MapLibre JavaScript library. It's very powerful, especially for 3D visualization. And this is the one that I've been working on the last 2 to 3 months. I've added over, like, I think almost 100 examples, so you can check out the link over there. It's very cool. So the first one, for example, you can visualize 3D buildings. So this one from the map tiler. On lower left corner here, there's a link, so you can open using your cell phone. You can actually visualize that in your cell phone. It's all 3D buildings, so this is like hundreds of gigabytes. It's just one line of code. It's just, actually this one, the one I'm showing here, 2 lines of code. So you can create 3D maps, 2 lines of code. How cool is that? And also all the examples is a no Yeah, you can click the notebook, you can run it, you can reproduce it. So everything I'm presenting here, you will be able to try it out yourself. So for example, visualize building in 3D, and you can also change space map easily, very much similar to iPad. Also, for example, you can visualize 3D terrain. So you can, again, this is all the examples, pretty much 2 to 3 lines of code, very easy to create. And you can also visualize movement data. So if you're working on GPS data or trajectory data, and this can actually update the data in real time. So imagine you have the sensor collecting the data, sending to the server, and then you can trigger the event. The data can feed into the program, and then you will update in real time. So this one's just showing the hiking trail. And then if this is something you want to create, you can also do that easily. It can be vehicle, it can be person, human, it can be animals or something like that, and you can drag the data on top of the 3D terrain. Again, this is only like a couple lines of code, so it's not very difficult to do using the Map Library Python package. You can also even display video. So sometimes you want to display video on the map. So this one shows you, for example, you can see the wave. You can actually also enable the 3D. So you can actually, just like you are there, you can see the wave is moving from offshore to the near shore. You can also simulate something, the trajectory, for example, in this case, the mark of an airplane along a path. The next thing is you can see that it's actually shifting or based on the path, so it's not one straight line. So you can see the icon actually is moving. The orientation is different, depends on the line, basically the orientation of the line. This is not something you can do easily using other mapping libraries. So Map Library is very powerful. You can also draw, for example, things on a 3D map, right? So this is rendering a 3D terrain, and you can create this polygon, for example. It's actually dragged on top of the 3D, and you can also make changes. It's pretty cool. You can also create marker classes. So this is also very common, especially for points, crime data, any points data. This is something useful that you can create. You can also create heat maps. So there are lots of options that are available. You can visualize any, similar to the iPad Live, you can visualize any raster data, remote sensing data, COG, GeoTIFF, stack, either locally or in the cloud. It's all supported, so you can just point to the data, and then you can just stream the data. You can change the color map, different band combination, super easy to do. So try it out. You can also visualize Google sensing data. So if you use Google sensing cloud computing, there are some data. For example, this one shows you the global land cover data. It's many gigabytes, so you can render the data. And then when you zoom in, you can also pop out the 3D. So you can combine data from multiple sources. You can from the local computer, from the different cloud providers. Everything can be rendered on the same map. So this is pretty much everything is at a global scale. So it's very cool, and it's very fast and also very responsive. Last example, this one is overture data visualization. There are a couple talks here at this conference, they're talking about overture data. But if you ever need to and visualize the overture data in Python and Jupyter environment, then Leafmap can help you. So again, if you're looking at these examples in here, how many lines of code to create this one to access the overture data? 3 lines of add overture data, specify the sim, building, transportation, whatever, and then just display the map. And then you will render the 3D if you're using a 3D. So for example, this one shows you the transportation, the roads, the connectors, and it's using the PM tile. So it's really fast, and you're loading the data at the global scale, several hundred gigabytes. It can render without any problem. And the nice thing is also 3D. So if you view in 3D, you can do that as well. Super easy to use. Again, there's a link at the lower left corner. You can open using your cell phone to see it using your phone. And so that's all the example I want to show you, but it's not just working in the Jupyter environment. You can also deploy in the web, as a web app, so that other people don't need to know coding. So my goal is that I do all this coding. You don't need to do many lines of coding. But if you really want, you can make it like no code, and then you can deploy. So I provide some example here. You can go to check out the link there, the example set. So you can just pretty much use these. After you develop the examples, you can just deploy on Hugging Face and just change a couple lines of code. You can, for example, Gmap, Leafmap, all the mapping libraries, you will be available there. So you can just deploy. Everything is free and open access, so you don't need to pay anything to host your environment. And you can see you can point the data to any cloud providers, and you'll be able to access all the data either in 2D or 3D environments. And again, there are lots of templates available that you can try it out. So this is one, and also, for example, earlier I mentioned the open data. So if you have you use that for some visualization of those high-resolution area satellite imagery, you can also use this one. So you see here, everything is bidirectional. So if I click on the map, you will query the data, and then you can just do interaction. So it's very powerful compared to, for example, Folium is just one way. Once the map is displayed, there's no way you can get coordinates back to your program to do computation. But I believe they can do that. And also the backend in this one is using Solara. So it's also a new package that makes it easy for you to use those packages on the web. And lastly, if you want to learn more, you're welcome to check out the Open Geospatial Solutions GitHub organization. So this is the one that I created and maintain. And Leafmap is just one of those. And so all those are the ones that I created and maintained myself during the last couple of years. And other popular ones, including Gmap, also Second Geospatial. And everything is open source, MIT license. You can use to do whatever you want. You don't need to ask me for permission. And I also have a YouTube channel. So if you want to learn more in depth how I use those packages and also how to develop packages like that, you're welcome to check out the YouTube channel. So I also teach at a university. And so all the courses that I'm teaching in class, I also record the screen and share on YouTube. So if you want to learn more, for example, this is the one that I'm teaching this semester. So it's 4 weeks now. So it's Intro to JS Programming, basically teaching how to, from no background in programming, how to get started and how to use all those open source packages to do geospatial data visualization. All the course materials, all the videos are available online, and also the lab assignments. So if you're interested, you're welcome to follow the materials, and happy to connect. So if you're interested in talk with me, you can connect with me on social media, or you can post questions on GitHub. I'm available 24/7 to answer your questions for free. Thank you. That's all I have. Yeah. Right. Yeah. Any questions? Yes?
I have a question about putting legend on like a map. How way you can do that? Leafmap?
Yes, one line of code. If it is built-in, or you can 2 lines of code. Yeah. So map.add legend, and then just provide the dictionary, and then the dictionary key and value, basically the key and the color. So you can, if you want, I can show you here. If you go to this, let's see here, Leafmap, and you should be able to find. So all the tutorials are available here. For example, all the map library, the one that I showed earlier. So this is all for 3D. So you can see tons of examples in here, all the thumbnails. I think 90, 80 examples. I lost track. And in terms of the legend, so this one can also add a legend. So for example, this one here, for map library, for 3D, right? So you can add a legend, custom legend, LCD, whatever. So if you click on the map, it's going to show you how to access that. So for example, once you add the data, so this is how you add a legend. So it is common one that I already built in, an LCD. If it's not, you can always add a custom. For example, provide a key and also the color. Then you will add a legend or something like that. So it's very easy to do. Yes. Mm-hmm. Any other questions? Probably it's easy, so nobody usually asks questions. Yes?
How do we use the map libraries to show substance?
As long as if the data is in some kind of geospatial format, if it's raster or vector, any common geospatial format it should be able to handle, because you use GeoPandas to read the data, or raster IO to read the raster data. So if there's some kind of format, for example, it can be, I'm not familiar with subsurface data, but you can even do, like, for example, indoor 3D data. So as long as it's some kind of vector raster format, it can be able to visualize that. Yes?
Trying to start set up your own Jupyter Hub. How would you see this to get Leafmap exposed?
Oh, it's just a package, a Python package, either using a pip or a conduct force. So it's just pip install. You can use, even also has a Docker, you can use Docker as well. So it's very simple. It's being pre-installed in many of the Jupyter environment, previously on the Microsoft printed computer, but that one is going away, it's shutting down. But Whereabouts also have the Leafmap pre-installed. So it's similar to Folium and IPyLeaflet. So if you ever integrate some of those in the Jupyter Hub, you can install Leafmap as well. Yes?
I guess maybe a little bit. So it's going to be web app update.
Yes.
What's the, how do they get out in the Jupyter? How does that work?
Yeah, so if I'm interested, you go to, again, I mentioned here, if you go to Leafmap, and then you go to the Open Geospatial Solutions here, scroll down, there are some web apps template in here. So all of these, right now, I use the Python package called Solara. So if you go to, for example, Solara template or maybe Geospatial, and you can look at the source code. For example, this is what it render after it's being deployed on the web. So it can be, it doesn't have to be Hugging Face. It can be any web server, as long as it can basically run the Python script, and then similar to Streamlit, very much similar. The internet is not working, but I can see here, I can open the source code. And for example, for Leafmap, it's not.
It's the code right up.
Yes, yeah. So yeah, under the pages, you have multiple scripts, and it's going to read all the things in the folder. And then, for example, here you see it's just rendering the map element, and everything else like available through Leafmap will be available in here. Again, the web is not working, but you can try it out later. So it has a template for different applications, Leafmap, Gmap, all the examples will be all in here. So if you are interested in, just fork the repo, and then you can even just duplicate the space on Hugging Face, and then within a couple minutes, the app will up and running on under your account, like in no time.